question 9, we're asked about a statement that always applies to a damping force. So the key here is really to think about counterexamples to 3 of these 4 statements. The last one must definitely be true, if you can do that with the other 3. Unless, of course, you know offhand exactly which statement is always going to be true. So our statements are referring to a damping force acting on a vibrating system. So I've got an object that's oscillating backwards and forwards, backwards and forwards. And remember, the damping force is the force that's trying to slow me down at all times. So as I'm moving in this direction here, there's a force this way. If I start to move back this way, there's a force again that's always acting against me. So let's see if we can work out exactly what is going to be wrong. Think of a situation where, for example, statement A is not going to be correct. So it's in the same direction as the acceleration. They're saying the damping force is in the same direction always as the acceleration. So can we come up with a counterexample that shows me the acceleration in the opposite direction to the damping force? Well, as my object oscillates backwards and forwards, of course, and it might be easier just to sketch it out. So here's my pendulum here. The acceleration, of course, is always acting towards the centre. Very badly. Because the force is always acting towards the centre. If it was MA, the acceleration always acts towards the centre or towards the equilibrium position, to be more precise. So my acceleration is always acting down. Is there any situation when my force is acting in the opposite direction to that, when my force is acting in this direction? And the answer is yes. When my pendulum is swinging backwards, the acceleration is that way, but because it's swinging this direction, the force must be acting in the opposite direction. Therefore, statement A cannot be true. So we've managed to disprove A fairly nicely. It's in the same direction as the displacement. Is the statement for B. Is there any situation when that's not true? Is there any situation where the damping force is in the opposite direction to the displacement? So here's my situation here when the displacement is clearly positive. Is there going to be ever a situation when the damping force is negative? In other words, is the damping force working in this direction? And again, yes, there is. If my pendulum is swinging now in this direction here, then the damping force is going to act in a negative direction, even though the displacement is positive. Therefore, B can't be correct either. Let's pick statement D for reasons that will become immediately apparent. It's proportional to the displacement. Can that be true? Well, let's take the situation when the pendulum is at equilibrium. It's swinging back. So this is actually at this point where it's got its maximum velocity. So my pendulum has now reached the point where it's got 0 potential energy. It's all been converted into kinetic. And so at this point it's moving its fastest. Now, the faster it goes, the bigger the damping force is going to be. And yet we're told in this one it's proportional to the displacement. So if D was true, if it was always proportional to the displacement, then when the displacement is 0, the force must be 0. That cannot be the case. The damping force is always going to be acting against the direction of the velocity, which, by the way, was statement C all along. Whichever way we're working, the displacement, or not rather, let's try that again in English. Whichever direction we are moving, whichever direction velocity we have, the damping force is always acting against us, so it's always in the opposite direction to the velocity. So the answer for 9 must be C.